This video will present solutions to the VCE 2021 Mathematical Methods Written Examination 2, Section B, Question 1. This question concerns a cardboard box made by folding a rectangular sheet with squares cut from its corners, as shown. Based on the method of its construction, the dimensions of this box are x, the side length of the cut corners, by h take 2x, the shorter side, length h, with two x lengths cut from it, by 2h take 2x, the longer side, length 2h, with two x lengths cut from it. These dimensions lead, in part A, to an expression for the volume of the box for the case where h equals 25. This is equivalent to the expression given, with the 50 take 2x term factored as 2 by 25 take x. Part B. The domain of the volume function VBox is determined by the fact that it is greater than 0, so the dimensions must be positive, meaning that x is greater than 0, and 25 take 2x is also greater than 0, which means that x is less than 25 over 2. Part C. The derivative of VBox can be determined using the interactive menu of ClassPad's main app. Part D. The maximum volume of the box will be when VBox dashed is equal to 0, where its sign changes from positive to negative, and where x is between 0 and 25 over 2. This maximum volume and the corresponding value of x can be found using ClassPad's fmax command. Part E. The percentage waste is the area of the four 5 cm by 5 cm cardboard squares expressed as a fraction of the area of the 50 by 25 cm cardboard sheet. This fraction can be simplified to 4 over 50, which is equal to 8%. Part F, Part 1. This question now considers the general case, where the box is constructed from a sheet with dimensions h by 2h. The domain of VBox will be between 0 and h over 2, as the side length x must be positive, but so must be the side length h take 2x. Part F, Part 2. To find the maximum volume of the box in this case, an expression for VBox in terms of x and h is required. To find the x value corresponding to the maximum volume, the zeros of the derivative are required. This shows that the derivative, a quadratic function, has two zeros. As the derivative is a quadratic with the leading coefficient that is positive, then it will change from positive to negative for its leftmost root, and so the x value required is the smaller of these two solutions. The value of VBox for this value of x now needs to be found. This output can be simplified by tapping the Simplify shortcut. Part G. This question now considers the case where the box is made from a square sheet of side length h. Similar to Part F, a new expression for V-box and its derivative is needed. To show that the maximum value of V-box is at x equals h over 6, it must be shown that V-box dash equals 0 when x equals h over 6.